Hello, everyone. Welcome to Listening to the Wind, the regular interview series from the International Windship Association. And I'm very pleased to welcome Dr. Jonathan Kohler today. Jonathan, thank you for giving us your time today.
You're very welcome.
Brilliant. Jonathan, I'm going to do a quick introduction and then I'm going to hand it over to you for your presentation. So Dr. Jonathan Kohler, Emrina C. Eng, I never know how to say that, is a senior scientist at the Fraunhofer Institute for Innovation and Systems and Analysis ISI. His research interests are innovation theory, especially sustainability transitions, sustainable mobility, sustainable shipping and aviation, and simulation modeling of transitions using agent-based modeling methods. He's developed the Tship Model of transitions in shipping, used in the man-ahoy scenarios for low-carbon shipping. He produced the technology uptake scenarios for the study led by CE Delft on the analysis of market potentials and market barriers for wind propulsion technologies for ships. So many of our audience maybe will have seen your work, but not known who you are. So today it's my great pleasure to have you presenting who you are and your thoughts on this. So, Jonathan, without further ado, I'm going to hand it over to you and I will see you on the other side.
Right, I'll just share my screen. Okay, can you see my screen?
Perfect, perfect.
Okay, well, thanks very much for the invitation to speak today, Gavin. It's always a pleasure, and I think it's maybe a little bit different to some of the other interviews you'll have because my approach and my field is very slightly different as well. I'm going to talk briefly today about actually these MAN ahoy scenarios. And I think the important message for me is that these are really the first scenarios that I'm aware of that have really looked at how shipping can drastically decarbonize through the lens of a view of innovation as complete system change in shipping. Things like the IMO GHG scenarios are very, very carefully constructed, very, very detailed, but they don't have this idea behind them that the structure of what's going on is going to change. Other thing to say is this is joint work with my colleagues at Fraunhofer ISI and Frank Schetter. So what this scenario that I'm going to present today, which is a selection of one of four, is really looking at how things are changing in the shipping industry and how one can find a place for wind propulsion. The important innovation in the method here is that we're not just running my Tship model, we do, but that's only part of it, but we also develop qualitative scenarios to inform how the simulation model should be parameterized. So we've got a narrative, stories of what's going to happen, and then some simulation results, which I shall briefly present both of these. The qualitative scenario developed involves identifying key factors, and this enables us then to set some plausible assumptions for a scenario system change. The other important thing is that we did this in cooperation with industry-based workshops, where we got together industry experts, NGOs, and a couple of academics as well. And then I translated this into the Tship model to produce quantitative scenario numbers. The challenges for shipping that led MAN to give us this project were that they wanted, this is MAN Energy in Augsburg, they wanted to show how they could be actively involved in the intellectual leadership. I mean, they're diesel manufacturers, but they were open to other things as well. And they want to show how shipping can contribute to a decarbonized future. They wanted to find out what the important factors were, and really the study is intended to show different possibilities for the industry so that they can navigate through this period of massive uncertainty that they're facing. both through decarbonisation and the changes in regulations that are coming, and also through digitalisation. The way the scenario was constructed was to firstly do the qualitative side through looking at steeple factors, the so-called social, technical, environmental, economic, political, and legal factors. This is a standard scenario, qualitative scenario development method. You make yourself a long list, then you have a discussion with your customer and the industry experts. Boil these 47 factors down, in our case, to around 13, which I'll gleefully show in a minute, and then write stories around these factors. And the idea is that you have, over these 13 factors, consistent narratives for each of them that enable you to build different scenarios. So you say different, you have a view of how these factors might change in the future. You think up 2 or 3 possibilities, and then you can generate 2 or 3 scenarios which are consistent through all these factors. That enables you to develop future assumptions, in our case out to 2050 or so. We then talk to experts again in a workshop to validate these assumptions, and they then enable you to develop these scenario drafts. These are then also checked with the industry workshops and then interpreted in the Matisse model. And we also went back to the industry with the results of the model, and we had a discussion about what they liked about it and what they didn't like about it. And then the model was slightly modified, the scenarios were slightly modified. These are the key factors. Mostly fairly obvious, but naval architecture is one, how ship design will change, environmental awareness in society in general, low carbon fuels, climate change, global economics, the adoption of digital technologies, the oil price, of course, and requirements for logistics. So these are all relatively obvious. The question is, how will they develop in the future? And we did 4 scenarios, and the one I'm going to talk about today is the most optimistic in terms of decarbonisation. It's called behavioural and technical change. And the point here is that in this scenario, rapid change comes through both technology development and changes in attitudes in society. And starting from the top, these are the narratives that describe how these 13 factors will develop. I'm not going to go through all of them. I'm sure the scenarios are available on the MAN website, and they're therefore readily available in the public domain. I'll just point out a few main ones. Firstly, and most importantly, at the top, there is a basic mindset change towards sustainability and environmental awareness through a cultural change to an idea of sufficiency. This means that there's an end of rapid global growth, or the desire in politic and social decision-making towards maximizing your economic growth. There is an idea that you don't have to grow all your production to be wealthy. There is very strong climate policy. Fossil fuels are prohibited. In more general terms, there is still ongoing globalization. There is a mixed attitude towards digitalization, with the result that ships are operated manually, but with digital support. So it's not a scenario with fully automated shipping. And I think the end result of the scenario is that hydrogen fuel cells and wind technologies are adopted on a large scale. So that's the qualitative narrative of the scenario. I've just got another couple of slides now to talk about the quantitative results with the Tship model. I'm not going to talk in detail about how the model works. That's being published, and you can obviously get more details from me. But what it does do is implement transitions thinking, which is the modern, I can say, development in the theory of innovation for sustainability over the last 15 to 20 years now. And this approach, it looks through a particular industry, a particular system, to see where are the alternatives and under what conditions can these alternatives, so-called niches, grow? And in shipping, these alternatives in terms of propulsion technologies are all fairly well known. The important thing here is that there are a lot of alternatives, and ships are big enough to be able to implement all of these. And we've obviously seen that in the recent past with LNG and dual and fuel, triple fuel engines. The model also includes alternatives to operations, and it also includes a couple of psychological variables about decision-making for investment in new ships, about how willing is a charterer or a ship owner to accept changes in operations and slower speeds, and what are the requirements for new infrastructure. So the important thing about the Matisse model is that it tries to encapsulate not only the price and emissions changes for different fuels, but also these decision-making variables, which our wind study with CE Delft showed are actually critical. So here are the results that we generate for this scenario. Remember that this is a very optimistic scenario. It includes both attitude change and technological change. Just to run through it quickly, horizontal axis is the year, and the model effectively runs from 2020 through to roughly 2060 for this year. Up the y-axis, this is the share, the proportion of the global fleet new builds that adopt the different technologies. So this is effectively the number of ships for the different trades. It's differentiated through cruise, container, bulk, liquid bulk, service vessels, and a couple of others. So what proportion of all these new building vessels adopt the different alternative fuel technologies? The first thing to see is obviously that fossil fuels start as being very, very nearly 100% in 2020, and having parameterized these very strong assumptions about no fossil fuels, strong climate policy, the model can just about achieve a very small proportion of fossil fuel building in 2050. The fact that even though fossil fuels are banned, or rather emissions, we take the view that emissions are banned, and that then anything that's built using fossil fuels then has to scrub the CO2 out of its emissions at the chimney, at the stack. What are the alternatives that come up? In the short run, the light green line, liquid natural gas, as we have seen, that's more or less historical information now, is adopted to a certain extent, and as at the moment is really the leading alternative, but it doesn't take off because it's a fossil fuel. And obviously power to liquid fuels, the so-called e-fuels, are then treated separately. What we can see today is that there is significant development at an early stage, but significant development in these power to liquid fuels based on renewable energy. So that's one alternative that comes up, given the very strong incentives. The other alternative that comes up, and that's why I'm here talking today, is that I am convinced that wind can play an important part. There are barriers, but if you are willing to take the leap into the dark and change your operational systems, the way you run your ships, the way you think about manning your ships, the way you think about controlling your ships, the obvious advantage of wind is that it's got no fuel, so you don't have to spend money on fuel, which is a major part of operational cost for a conventional ship. I believe can provide the financial incentives that enable a major uptake, given the strong enough incentives to decarbonize. Okay, so those are the main results. For the report on the whole study, we derived these key insights for shipping. Firstly, and this is a big issue in shipping, very, very rapid action is required. Even in the scenario I just showed you, because I was assuming that up to 10% of the new build fleet would be rebuilt in a year, which is massive. It's very difficult to achieve a completely carbon neutral fleet by 2050. So we've got to start right away. Technology follows regulation. So if there are incentives, the technological development will follow regulation. And we've seen that in the case of local air emissions with the MECAs and SECAs, and now with the sulfur regulation. More unusually for shipping scenario, social attitudes matter. So if people are willing to say, we want decarbonized products, shipping is a part of that, therefore there is an extra pressure from the logistics side for the shipping industry to actually decarbonize itself. And this follows on to the next point, that this attitude change in society will cause a change in the logistics industry, and we are beginning to see that today. A message of warning for the shipping industry itself: if customers really do set their priority on clean shipping, then the industry must be prepared to act very quickly. And some firms are, and some firms are preparing themselves, but a lot are just saying, no, we are going to wait and see until the alternatives and the policies come in, which could lead them in a few years, the way things are going, into big problems. Okay, that's my very, very brief summary. Here are my contact details, and for any further information, of course, do get in touch. Thanks very much for your attention, and I'll stop sharing the screen. Over to you, Gavin.
Okay, thank you very much, Jonathan. Very interesting presentation, and yeah, as you say, that you focused on the most optimistic scenario there, and I know there are 3 other scenarios that were in that report. And I just had a quick question about those before I talk about the optimistic. Well, I'd like to think it's realistic, but there we go. But yes, the other scenarios. Did you see in those other scenarios a significant part for wind assist and primary wind vessels there?
Yes, but much later. The most pessimistic scenario is an initially do-nothing scenario, where eventually the EU implements relatively strong policy for shipping as the EU gets really worried about climate impacts. And then these alternatives do come through. And again, the advantages of wind, that it's carbon free and free, do eventually play out, but much later. I mean, the uptake starts in sort of 2040, something like that, which is obviously far too late to achieve the Paris goals.
Yes, and you know, I noticed, you know, on one of the slides it's the UNFCCC 2 degrees, but of course, you know, lower than 2 degrees and as close to 1.5 as possible. And from my understanding, that gives us about 9 years. If it's around 1.5, 9 years of business as usual emissions at a period of time when emissions are growing. So the urgency is certainly there. And the other question I've got around these scenarios is the likelihood of these scenarios panning out. Now, I know you don't have a crystal ball at all, but are you seeing indicators since the release of the report, and things are moving quickly, not always in the right direction, but things are moving quickly. Are you seeing indicators that are lending themselves or indicating any one of these 4 scenarios is increasing in likelihood?
Yes. Again, the optimistic view of the world is that just over the last 1 or 2 years, really, in shipping, from the conversations that I have, but not only in shipping, there is a growing demand for environmentally friendly products and transport. We're doing another European project for Horizon 2020 at the moment, which is looking at new needs in road freight and freight modeling for Europe. And we've done a load of interviews, and one of the things that's come out of that has been that policymakers are saying, we want to see scenarios of low growth, anathema normally to logistics and transport, but that's beginning to be an issue. And also, the industry is beginning to say, we are seeing people like Heineken's a very good example, of major companies saying, we are going to decarbonize, and we're not going to wait for regulation. We are going to decarbonize, and we see ourselves as market leaders. And the point there actually is that if society then moves further in this direction and more people want clean stuff, they have then got a big market advantage. So, so the optimistic scenario is not, in terms of how it might play out, is, I think, pretty reasonable. It's not a pie in the sky thing at all. The others, technological change, that's beginning to happen. There is also obviously a big possibility that the late action scenario will play out, because if you look at what's going on, to be blunt, in the UK and the USA and even China, I think the big shipbuilders, you know, they're all, the UK and the USA aren't that interested really in terms of their politics in climate change at the moment, for various reasons that we don't need to go into. And you don't see a real push to decarbonize shipping in the major shipbuilding countries either, really, yet.
Right.
Arguably, Japan is the most advanced, but China and South Korea, you know, they're just building the same old stuff, and they're beginning to think about LNG if they absolutely have to, and beginning to think about ammonia if they absolutely have to. They're just really pushing for it. So
it's a sort of multi-lane highway of people going at different speeds, a couple of guys maybe on the side not moving at all. But that regionalization, you know, in a sense, you know, looking at the graphs that you've produced, also one of the aspects that I've seen is that there are some significant tipping points that we potentially can reach, where, for example, a sector-wide realization on the technologies are available.
Yeah.
And I think we've already seen that, in a sense, over the last couple of years, of suddenly there's a light going on and say, actually, we've got the technology to do this.
Yeah.
And 5 years ago, that was very much not the case. So do you see any tipping point within the decade of wind propulsion, which it says behind me, that could be a significant one, maybe from policy? We've got a lot of policy coming through from IMO and the EU, for example. Do you see any significant tipping points there?
Well, actually, the tipping point for me is rather different. I think the policy processes in the EU are looking better for me than the IMO. I see the IMO is moving fairly slowly still. But the real tipping point is actually coming from within industry. And the adoption of the Poseidon principles, I think, is actually a very strong signal. And what could happen over the next few years is that, and I think our activities in the IWSA could feed into this, which is why I'm so interested in the accelerator activity, is that as soon as you actually get wind ships in the water sailing commercially, even as a demonstrator, but sailing and providing an actual commercial service, if you combine that with people starting to say, we are not going to invest into ships, we are going to invest in clean ships, that could then come together and enable a takeoff of low carbon shipping. That I think this combination of the demonstration of technologies, and that applies to the alternative power to liquid fuel or hydrogen fuels, they're still in the development stage, really. There are a few ships around, but not many. But when you see some bigger ships coming through and experience with operating them, that could then combine with this push from the finance and demand side to combine. That could happen quite quickly, by which I mean in the next 5 years even.
Yeah, and
yeah,
I certainly can see that as being a really significant driver there. And I think we saw some declarations, you know, COP26, a lot of people were disappointed maybe with the headline aspects of COP26, but actually there was a whole raft of declarations there. One being, the zero carbon. Sorry, I can't remember the actual name of it, but the zero carbon cargo pledge, where some significant companies and some countries backing that as well, but companies coming forward and saying, we're not going to wait for regulation. We want to have that zero carbon shipping, and I think it's by 2040. And they want a significant move by 2030. So green corridors are being proposed as well to help boost that, especially around fuel. So no, it's very, very, very interesting. And of course, we have the EU ETS, including shipping. How do you see the sort of NBM's carbon levy aspect playing out, and what impact do you think that will have on the uptake of wind propulsion?
Yeah, that's actually quite a tricky question. My work in not just in shipping but in transport in general has showed me that, of course, prices of fuels are important, and all these market-based measures effectively put an environmental levy on the operational cost of your transport, whether it be on the fuel itself, which is often the case, or on the emissions through the fuels. And that, of course, then puts the prices up and gives you an economic incentive to do something about it. The problem being is that, and again, this is a general problem in transport, but also in ships, if you've got ships sailing around with, let's say, dual fuel motors for LNG and diesel, or LNG and heavy fuel oil, you need quite a big incentive to say, well, we're not going to run the ship like this anymore. We're going to refit our engine, for the sake of argument, for hydrogen. That involves a lot of expense and a considerable time out of the water. And those sorts of expenses are not going to be covered by the sorts of carbon prices that we're seeing in the EU ETS.
Right.
So it is an incentive, but for me, it's a marginal incentive. And the prices that will produce major changes, where you're talking about hundreds of dollars or euros per ton of carbon CO2 or carbon CO2, they're just, if the market starts to move in that direction, there will be a massive pushback from the industry lobbies, and they would say, "No, we've got to have a price cap. That can't happen." So I'm not saying that prices aren't important. They are, but fuel prices will change your short-term decisions. It'll certainly lead to slow steaming, and that's a good thing. The other important question, though, is the investment side. Where is the money coming from for an investment? And unless that is one thing where the market-based measures could help, if you then channel the income from the market-based measures into investment support,
right?
That, I think, could be quite a significant
plan. So on the basis of, say, an expanded Norwegian NOx fund type approach, where it's brought back in to support low-cost loans or grants to actually decarbonize the ships. No, indeed. And from some of the discussions I've had, and I'm sure that you have had in workshops and other ship owners, the price of fuel certainly is the backdrop to the discussion. So once it goes over a certain amount, the door's open to, let's discuss these new technologies. It doesn't mean those new technologies are going to be implemented, but the discussion is there to be had, and certainly as a driver, but not the only driver. And I'm just wondering, the impact of black swan events, and I don't actually think this is a black swan event, but I'd say it's more of a grey swan event. For example, COVID, and the impact that had, or is still having, on the industry. Do you think that such events, and COVID in particular, has had an impact on the viewing of innovation, or the view of, are we able to make this change in time quickly enough to meet the challenge of climate change, for example?
I'm not sure, to be honest. there's one argument that says actually COVID hasn't changed very much in people's minds, and if the next Omicron wave or whatever is shown to have relatively minor effects, and we go back to living life as we did before, and the only real changes that you will see are and I think these are important, but not immediately directly for the shipping industry, are this increase in e-business and home shopping, things like that. That then changes the organization of logistics and distribution part of freight transport, but wouldn't really have so much direct effect on shipping itself, I don't think. That's one argument. The other argument, though, is that if you really do see a major threat, and this in our case, this will be the major threat from climate change, there is now a new willingness certainly in the Western countries that have been in recent years very much, no, you want to keep your markets efficient, and we want more globalization, and we should let multinational companies optimize their global supply chains. There may be a greater social willingness to accept government regulations.
Right.
And so it's possible that effective COVID will be, as climate change impacts ramp up, and I'm personally convinced that they will, there might be a more rapid reaction on the part of society to say, not just to say, oh shit, but to say, oh shit, we're going to do something about it in terms of imposing decarbonisation regulations. And I think that one result could be that these regulations come faster than they would have done before COVID, because people and societies have seen it happen, and they've seen that you've got to do something, because if you don't do something, you end up like Brazil or even arguably UK, doing worse in terms of outcomes in other countries.
So the appetite maybe has changed from we'll do anything as long as it's pain-free to actually a realization that we can make a fundamental change if the imperative is there. If there's a strong enough negative driver, we're willing to accept a bit of shorter term pain to make that transition. Yeah, that's an argument I've certainly heard. I think the jury's out on what's going to happen, and from most of these issues, 5 years, 10 years down the line, business as usual seems to creep back in, and it's quite a how can I say that inertia is very strong and very hardwired.
And for me, the important thing that is, as I said, that's true in the case where you don't have any more information coming in. But if climate change impacts ramp up over the next 10 years, that the argument there is that these new effects that society is seeing are coming into a society that's more sensitive to how these things might play out.
And of course, ship owners will return and say, look, we're businesses, we've got to be profitable. So yeah, it's always going to be that trade-off of keeping the wheels moving, but also being not just sensitive, but moving in the right direction.
Yeah, and things like carbon prices apply to whole fleets, so you've got to make sure there's something that applies equally across the board towards all the operators. But then also you've got to say, okay, if you want these changes, you've got to make the finance available for these innovations and for these developments. And of course, that's also a big issue in shipping.
No, absolutely, and we've taken quite a helicopter view, quite a wide view of innovation and development. So I'm gonna narrow it down a little bit and give you some quick fire questions now around wind propulsion and around yourself and the work that you're doing. So first of all, if you had to pick the most significant remaining barrier to the uptake of wind propulsion at scale, what would that be and why?
For me, the worst barrier is actually the fact that ships sail slower. And In the logistics industry, the emphasis today is on everything being faster and faster and faster. You get everything to the customer faster and faster and faster. And the idea that you then slow down your operations is then, it's a sort of disconnected, a contradiction.
So slow steaming, you know, there's some great believers in slow steaming. There's others that say this just means we have to have more ships to deliver the same amount of quantity in this over time. Yeah, and I think that disconnect. Sorry, I'm going to jump in and make it. I think that disconnect is quite interesting with the siloed view of, you know, speed and fuel, but actually speed reductions generally will also lead to benefits from a higher ratio of wind potential for that vessel as well.
Yes, and actually all this stuff about speed it's actually a bit of a mirage, because what people want to be able to do is to know when their goods are going to arrive. For most things, if you're shipping stuff from China, you're in the logistics business, you want to know when the goods are going to arrive in your port. With modern digital technologies, what you can do is you start shipping the stuff before it's ordered and before it's demanded. You predict, and as the algorithms enable you to predict, okay, if your ships are saying slower, you send off more a bit earlier. So it involves more cost in stock in transport, but it doesn't actually prevent you from achieving very short delivery times.
So you get more of a sort of conveyor belt approach, where it's just you're just putting this stuff on, knowing through AI or whatever other predictive software you're using, that it's pretty likely that those things are going to be ordered because they have been over the last 10 years or whatever it may be. Yeah. I think for bulk goods, that's also potentially a measure easier to do as well.
Well, no, it happens with food now. They're talking about getting rid of distribution centers, and you start producing your food, you put it in your lorries, you consolidate your goods, and while the lorry, so this is relatively short range transport, is in transit, you decide where it's going to go.
Yeah, I'm pretty predictable around my Jaffa cake consumption.
Yeah,
so
that's one of the things about digitalization that's changing.
No, indeed. Now I'm going to bring it back to you. How, you know, this shipping, innovation in shipping is quite an interesting niche area. How did you get into this area of research and area of interest?
Well, it started a long time ago. I studied mechanical engineering originally at what was then Coventry Polytechnic. At the time, I was interested in things military, tanks, planes, but also ships in a big way. I'm not a big sailor, but I'd sailed to a certain extent, so I had interest in shipping and military ships. And when I got my degree, I got a job with the Ministry of Defence in what was then the Royal Corps of Naval Architects, the Design Bureau and Shipbuilding Bureau for the Navy. So I had a long-term interest in ships. And then I went out of that industry, did a PhD in economics, then got into climate change analysis, and came back to Fraunhofer. Well, not back to, but came to Fraunhofer because I became convinced that economics, on the whole, is not very good at looking at these sorts of things, large long-term changes, and innovation was the key to what's going to happen. And so, really, what I did was just combined this newfound interest in theories and ideas around innovation and how that happens interesting with this liking, with this old history for me of shipping.
Right. So kind of full circle, return voyage.
In a way, yeah.
Yeah. No, that's great. And I'm going to ask you around the work that you do. This is innovation in an industry that's not always that open to talking about competitive advantage areas of development. What's the biggest issue that you faced in moving your research on and really reflecting what's happening in the industry?
The biggest issue is actually that in shipping, there is, as with many industries, they want to do their scenarios and their innovation planning for themselves internally. That makes then me as a researcher often a little bit on the outside. There are, and it varies, but it's actually quite difficult to find money as a researcher to actually research for a research innovation in shipping and change that are coming. A very good example is access to AIS data.
Right.
It's really expensive. You know, it's sort of €10,000 for a single data set. That sort of money. And within a research project, you've got then to have that sort of funding. It's not something that you can do, you know, as a researcher at the weekend or anything, unless you're a pretty rich one. I think that's quite a barrier.
Right.
And,
so access to data, access to internal reports or information. Right.
But also the willingness to get somebody out, and all credit to MEN. They didn't give us a lot of money, but they gave us enough money to run a project. I was able to modify my model slightly and spend a little time working on it. And that's actually very unusual.
And have you seen collaboration within the industry? You know, you've been in this area for quite a few years now. Have you seen that changing over time? Is there a transition to maybe more openness, more collaboration in the industry to get these technologies over the line, to get these innovations hardwired into the industry?
Yes, but the industry is being dragged into it kicking and screaming, is my assessment. So it is absolutely true that shipping, compared to 10 years ago, knows that things are changing. All this decarbonisation stuff, it's forced them to change. They know they've got to change. And at the same time, there is then a lot of project, not massive amounts, but quite a lot of project money coming out of the EU for new propulsion technologies, new fuel systems, and all that stuff. And this requires you inevitably to work collaboratively and bring different skills together. So the industry, there is some money out there. The industry is saying, okay, or at least some of the players are saying, okay, yeah, we'll get this money and we'll go and do development. And when you're in these projects, though, there's always a big conversation about non-disclosure agreements, who's allowed to say what to who. And so but these are all intelligent people. They know that they've got to implement these changes. Therefore, they know that there is expertise they haven't got. So they are coming together. But it's always difficult at the moment. So it's still not really a culture of, okay, we'll find a way to work together and then we'll sort the problems out. And then we can find a new market and we'll all be happy. It's all, are they trying to nick our knowledge? Are they trying to get our expertise and use it for themselves? That sort of thing.
Well, I think when you have an industry where pretty much 50% of your bottom line is around fuel and the usage of fuel, that's your competitive advantage in many cases. So yeah, it's
so it's a tightrope, really. So you can understand it. But in a world where you've got to change fast, being reluctant and therefore being slow is unhelpful. Let me put it that way.
Very, very diplomatic, but so my last question is on the future, and you're the man with the crystal ball. I'm only joking, but I'm going to talk more about the work that you're doing in the future. Research areas that you're interested in, and also if there are any opportunities for researchers that are watching this to get involved in projects that you're developing in the future.
Yeah, well, we'll have to see. I work in Fraunhofer, which is external project money driven. So at the moment, they're trying to get money out of the Horizon 2020 program. I've also engaged in cooperation with a couple of PhD students occasionally, so that's always a possibility. the one area where I've been trying to get money for but haven't managed yet is to extend the Matisse model to really look at refits as well as new builds. I've done a little bit of the programming, but it needs a project to really bring that together and make some proper scenarios. And the reason, and that's, it's not yet really being addressed in a big way by the industry. It's mentioned, but if you're going to have these very, very, very rapid changes, my scenarios really show that you can't do it with just new buildings.
Right.
So to achieve the Paris agreements, you're going to have refits as well as new buildings. And I think that's an area of research that needs to be expanded.
And especially in the time period we're talking about, with assets that are 20, 30 year
Exactly.
lifespan. So pretty much the ships we're developing now or building now are going to be still operating in 30 years time, and most of those are not anywhere near being zero emissions themselves. So
and again, that's an advantage of several of the wind technologies, that they're relatively easy to refit compared to completely changing, trying to install a liquid hydrogen system down in the depths of your ship, and you don't know what size and what shape your tanks are going to be. But, you can't do the same as diesel, so you've got to start heaving things out of the double bottoms and things like that. Big expense. Whereas if you can fit a wind device, whatever it may be, on deck, provide the structural strengthening, then it's relatively easy. So I think that's
and I think we could probably have a whole other 3/4 of an hour discussion around things like modularization, around things like creating wind ready new builds. If they're not ready to put the wind on directly, then they can retrofit it easily later. But maybe to be continued. And we can revisit that in 6 months or a year's time, and hopefully there'll be some research and grant funding coming through for a real forensic look at that area as well, because I think I agree with you, it's really important. But I'm not gonna dominate the end of this interview. I'm gonna say thank you, Jonathan, or Dr. Jonathan Kohler from Fraunhofer ISI, for joining us today, and a really fascinating look at the potential scenario around the uptake of wind and other technologies, of course. But I'd like to give you the opportunity to finish the interview with a brief summary or a takeaway that you'd like to give to the audience.
Yeah, and thanks very much for inviting me and giving me the opportunity to have the conversation.
My pleasure.
I think for me, the key message that I want to give to the wind part of the marine industry and shipping is that we should be optimistic. We're almost at the stage where you can make a big case, a very strong case for wind shipping. And there are lots of good designs, there are lots of good technologies out there. Some of them are actually beginning to be built. And it just needs that push for the industry in general, the logistics industry, to say, okay, this is a realistic alternative. And my scenarios and the work that I do shows how it can be possible. And the more recent work that's showing that there is this change, beginning to be this change in the structure of demand, gives you real room for hope.
Well, I think on that note, and I like the hope, the word hope, or I like to maybe change it to expectation, but hope is good. We keep it at hope. Jonathan, thank you very much for taking your valuable time to come and sit here and talk through a fascinating area. And I think the rest of this decade is going to be an incredibly interesting transitional period. So I'm really excited about that. I'd love to have you come back. Yeah, as I said, maybe in a year's time, and we can update what's been happening over those last 12 months. And to the audience, yeah, thank you for joining us. And I'm sure that Jonathan will be more than happy to answer any specific questions around his research. Yeah, and the email address was on the presentation slide. And of course, if you want to discuss anything wider about wind propulsion, then IWSA and myself are always here to answer those questions too. So without further ado, I'd like to say thank you very much for joining us. Thank you, Jonathan, for your time, and fair winds to all.
Right.
Thank you.
Fair winds, everybody.